You've probably seen those incredible new AIs, right? The ones that can look at any photo and just describe it perfectly, or even answer questions about it. It honestly feels like magic. But here's the thing, that magic takes a massive amount of computing power. So the real challenge, the billion-dollar question, is how do we get that brilliant AI out of the cloud and onto the device that's right in your pocket? How do you shrink an AI brain that's the size of a jumbo jet and make it fit on your phone? Well, let's dive in.
Just pause and really think about that for a second. What if you could point your phone at some weird plant growing in your backyard, or a super complex chart at work, or even a street sign in a language you don't recognize, and your phone could just tell you, instantly, what you're looking at?
Okay, so you and I, we see a cat stretching, right? But get this, a new kind of AI can look at this exact same picture and generate a description like, a Siamese cat is stretching its front paws on a red brick patio with greenery in the background. See, it's not just recognizing cat, it's understanding the action, the breed, the environment, the entire context. This is exactly the kind of leap we're talking about.
So, that brings us to our first section, AI that sees and talks. Let's really break down the tech that makes all of this possible.
It's called a Vision Language Model, or VLM for short. And the easiest way to think about it is like an AI with two halves of a brain working in perfect sync. One half is an expert at computer vision. It gets pixels, shapes, and objects. The other half is a master of language. It knows grammar, context, all of it. A VLM is what happens when you fuse those two skills together.
And the applications for this stuff? Oh, they are absolutely revolutionary. We're talking about self-driving cars that don't just see a stop sign, they can read it. Smart cameras that can describe exactly what happened. We're even talking about portable medical devices that could analyze an X-ray in a remote village miles from a hospital. It's a massive, massive leap forward.
But there's a huge catch. These incredible AI models are, well, they're huge. And I mean unbelievably big. This is what's known as the billion parameter problem.
To put this into perspective for you, a large model like GPT-3 needs around 350 gigabytes of memory just to run. Your phone might have what, 8, maybe 16 gigs of RAM total? Trying to run that AI on your phone is literally like trying to park a jumbo jet in a one-car garage. It's just not going to happen.
And this gets to the core of the issue, this battle between cloud AI and what we call edge AI. Cloud AI can be all-powerful, but it's often slow because your data has to travel all the way to a server and back. There's that lag, you know? But for AI on the edge, on your device, the rules are totally different. It has to be lightweight, incredibly fast, completely private, and it better work when you're offline.
So how do you solve this puzzle? How do you take that jumbo jet and shrink it down into a high-performance drone without losing all its power? Well, the answer lies in some seriously clever techniques for shrinking the AI brain. Let's look at the top 3. First up is something called pruning. Honestly, the analogy here is perfect. Think of a gardener trimming a bush. An AI model is just this massive, tangled network of connections. And it turns out a whole lot of them aren't really all that important. Pruning is the process of finding and just snipping away these useless connections, which makes the whole model smaller and way more efficient.
Okay, next we have quantization. Now, an AI stores its knowledge as a bunch of numbers, and these numbers are usually super precise. Quantization is basically like taking a giant, high-resolution photograph and saving it as a much smaller JPEG. You reduce the number of colors, or in this case, the precision of the numbers, but the main image, the AI's core knowledge, is still totally recognizable. And this shrinks the file size a lot.
And finally, this one's my personal favorite, knowledge distillation. This is where it gets really cool. You take a huge, powerful teacher AI, that 350 gigabyte genius, then you create a brand new, tiny little student model. The student doesn't learn from tons of raw data. No, it learns by watching the teacher. It just tries to perfectly mimic the teacher's answers, and in the process, it distills all that incredible knowledge into its much smaller brain.
So for example, the massive teacher model might look at this and say, that's a cup, 90% confidence. The small student model then trains over and over trying to match that exact output. Eventually, it learns to look at the same image and give a really similar answer, like, that's a cup, 86% confidence. It has captured the essence of cupness from its teacher, but in a form that's thousands of times smaller. So look, these shrinking methods are not just some theory in a research paper. They are being used right now to bring powerful AI to the edge. Let's check out some real-world examples. These techniques are leading to some major breakthroughs. We're seeing models pop up like Mobile VLM V2, which is specifically optimized for the phone in your hand. Then you have things like Moondream 2, which is so incredibly tiny it can run on a simple Raspberry Pi. Think about that. That means powerful AI can be built into almost anything. But the real takeaway is speed. Models like Mini VLM are slashing processing times by over 90%. This stuff is happening now.
And you know what happens when there's big innovation? Big investment follows. The market for the special hardware needed to run these models on the edge is projected to absolutely skyrocket to nearly $4 billion by 2025. This is a massive industry-wide bet that on-device AI is the future.
So the process for actually getting one of these models out into the world follows a pretty clear path. You start by collecting your data, of course. Then you choose an architecture that's already built to be lightweight. From there, the engineers work their magic, using pruning and quantization to fine-tune it for a specific device. And finally, you deploy it and let it keep learning and improving over time.
Which brings us to the most important question of all. So what? What does all this actually mean for us? Why does shrinking an AI brain and putting it on your phone actually make our world smarter?
Well, it matters for 4 huge reasons. First, speed. You get instant, real-time answers, which is absolutely critical for something like a self-driving car. Second, privacy. And this one's a big deal. Your personal data, your photos, they get processed right there, on your device. They're never sent to a company's server. Third, reliability. It works on a plane, in the subway, anywhere, no internet required. And finally, accessibility. It puts powerful tools like medical diagnostics into the hands of people anywhere and everywhere in the world. All of this leads to one final, fascinating question. We are on the verge of a world where our everyday devices, everything, can see and understand what's around them. So when everything from our toasters to our cars becomes intelligent, what are we going to build next?